Hello all. In this video session I'll be discussing about the following programs. That is program to read and print elements of a matrix, to find sum of elements of a matrix, to find transpose of a matrix, to find sum of two matrices, and to find product of two matrices. We have already discussed the logic of first two programs, so I'm just going to show the implementation of these two programs and their outputs. Okay, this is an algorithm written in the form of a pseudocode. I will just explain the programming code. This is our programming code. So first statement is hash include studio.h, that is to include standard input output files so that we can use printf, scanf, gets, puts, functions like that. Okay, so functions like that involve input and output operations. Then hash define max. Hash define is a macro. I just want to define a constant max, and value of max is 10. Okay, and after that we have main, int main, and so I have given return 0 here. Okay, then after that I have declared the matrix, that is int mat max max. So the compiler will statically allocate a matrix of size 10 by 10. Then we have m and n, that is a size provided by the user, a size required by the user. M is the number of rows, n is the number of columns, I is the variable using which we will be iterating through the rows, and j will be the variable using which we will be iterating through each element in a row. Okay, now next a message to the user to enter the size of the matrix, and it is read and placed in variables m and n. Okay, since it is integer, inside scanf we have given ampersand d, and in scanf we have to provide the address of the variable. That's why it runs ampersand m and ampersand m and ampersand n. Okay, now for reading array elements, like we discussed in our last video session, we will require two loops. Okay, here two for loops are used. So for I equal to 0, I less than number of rows plus I. Then for j equal to 0, j less than number of columns plus j. Then printf enter the value at mat of percentage d. Here value of I will be replaced with percentage d. Here value of j will be replaced with percentage d. Okay, then after that we have the scanf statement inside double quotes percentage d, that is to tell the compiler that we are reading a integer value. Then we have to place it at mat of ij, so the address is given ampersand mat of ij. Okay, now for printing, here just I have copied these two for loops, and for printing I have just given the percentage d, indicating that it is a integer value, and then to read the value I have given the name of the variable, that is mat of ij. Okay, so it will be reading the value from location mat of ij. Okay, so I didn't consider the spaces required. So if I just compile and run this program, the output I get is, okay, matrix dot and gcc matrix dot c hyphen o matrix dot out dot slash matrix dot out. So I'm just going to give it 2 and 2, and I'm going to enter 1 2 3 4. Okay, now if you observe, all the elements are printed in the same line. Okay, so in order to provide space after, we have to provide space after each element, and also we have to provide a new line character after each row. Okay, now if you consider this loop, this for loop, that is for loop involving I is for iterating through the rows, and for loop involving j is for iterating through each element in the row. So after each element we require one space or two spaces, so I'm just going to provide here two spaces. So after every element there will be two spaces, and after this for loop exits, that is for loop involving j exits, okay, we should provide a new line character. So end of this loop indicate that one row has ended. Okay, this for loop is used to traverse through every element in a particular row. Okay, and after that we will be putting a new line character so that it will be printed in new line. Okay, so I'm just going to put a backslash n here, and I'm just going to save this, and then I'm going to compile it. No errors, so I'm just going to run it. Then again, size is 2 rows and 2 columns. Elements are 1, 2, 3, and 4. Okay, so the matrix is printed in a proper format. Now just consider that I'm just going to run this program again. Size is 2, 2, 2, and 2. Elements are 1, 11, 111, and 1011. Okay, now if you observe, they are not printed in proper format because the number of digits are different for different elements. Okay, first element is 1-digit number, second element is 2-digit number, third element is 3-digit number, and fourth element is 4-digit number. So the spacing is not done properly. Okay, so if we can allocate same space for each digit, okay, that is the same space for each element, then this formatting problem can be solved. Okay, and the C provides a facility to provide number of spaces taken by a particular integer by providing value in this percentage. Okay, while printing in this percentage d, if I specify 5 minus 5, okay, then what it does is that it will provide 5 spaces for, or 5 total space for a number as 5. Okay, so if it is 1, then it will write 1 and then put 4 spaces. If it is 11,111, then it will write that number as such. If it is 111, then it will put 2 spaces after 111, so that every number will be taking the same space. Okay, I'm just going to save this, then I'm just going to clear this, and then I'm just going to compile it, then I'm just going to run it. Okay, I'm just going to give sizes 2 and 2, first element 1, second element 11, third element 911, fourth element 1111. Now if you observe here, 5 spaces are taken by each element, so the format is maintained. Okay, now if you observe here, minus 5 means that first digit will be, or the number will be printed, and then the spaces will be added, or space will be appended. If there was no minus, then spaces will be printed first, and after that the number will be printed. There is a difference between minus 5 and plus 5. So this is how a matrix size is read. Then all the elements of a matrix is read, then we print that matrix. Okay, so don't forget, while we are printing the array elements, after while printing the matrix elements, remember, while printing the elements, after printing each element we should provide space, and also after printing every element in a row we should provide a new line character, or we should print a new line character. Okay, now we are going to discuss about the program to find sum of elements of a matrix, and this is actually an algorithm in the form of pseudocode for finding the sum of the elements of the matrix. The logic is very similar to the logic used for reading the elements of the array as well as for printing the elements of the array. Okay, similar logic is used here, only here sum equal to sum plus mat of ij is given. That is only difference. Otherwise most of the statements are same as our previous program. Okay, so this I'm just pasted the previous program, that is a program to read and print matrix elements. So the steps hash English dot hash define max into main, then reading the size of the matrix, that is m and n, then reading the elements of the matrix. These all statements are the same. Then this is not required, so I'm just going to delete it. Then this is for actually for printing, so I'm just going to delete this. This is not required. Then for traversing through each element, this is the statement required. Okay, so if we use this for loop, we will be traversing through each element of the matrix, and while we traverse through each element of the matrix, we can add those elements to find out the sum. Okay, for adding, I'm going to use a variable sum, and I'm going to initialize it to 0. Then here I'm going to give sum is equal to sum plus matrix of ij. Okay, so whenever it traverses or it goes past, it traverses through a matrix element, it will be added to the variable sum. So after executing or after completing all the iteration of the for loop, the sum, total sum will be stored in the variable sum. So after that, I'm going to printf sum of matrix elements is %d. Then I'm just going to give /n, then comma, then sum. So the value will be read from the sum and will be placed at this %. Okay, so this is the modification I made. I just changed this statement. Then finally, for printing the sum, I have written this statement. Okay, so I'm just going to save this, and again, okay, and then here I'm just going to give GCC sum of matrix elements.c and output it to sum of matrix elements.out. Okay, I'm going to run sum of matrix element.out, and it is asking for the size, so I'm just going to give 2 elements 1 2 3 4. Okay, so the sum of the elements is 1 plus 2 3, 3 plus 3 6, 6 plus 4 10. Okay, so this is how we are finding out the sum of the elements of a matrix. Okay, next program to find transpose of a matrix. We have matrix A, which is of order m by n, where m is the number of columns and n is the number of columns, and T is the transpose matrix of A. Okay, and if we consider, for example, take this matrix, it is matrix A, it has 2 rows and 3 columns, and these are the elements. And in order to find the transpose of matrix A, we have to write all the columns of A, all the rows of A as columns. Okay, so all the rows of matrix A will be the columns of transpose matrix T. Okay, so here row 0 will be column 0 of transpose matrix, and row 1 will be the column 1 of transpose matrix. Okay, so here row 0, column 0, row 1, column 1 in the transpose matrix. If you observe here A of 0 0 is 1 and T of 0 0 is also 1. A of 0 1 is 2, and here T of 1 0 is 2. Here A of 0 2 is 3, and here T of 2 0 is 3. In general, we can say that A of ij is equal to T of ji if this T is the transpose matrix. So we can find the transpose matrix elements by using this equation, that is T of ji is equal to A of ij. Okay, another thing to remember is that once we find out the transpose matrix, the order of the transpose matrix will be n by 3. Order of matrix A was m by n, so the order of transpose matrix T will be n by m. Okay, I have copied the program to read and print the matrix elements, and I'm just going to modify it. I'm writing the program to find the transpose of a matrix. Okay, I have given the name of the matrix as A. Okay, and I'm just going to enter the variable for storing the transpose matrix T of max. Then here I have entered the size of the matrix. Then I have entered the logic for entering the elements. Then this is the logic for printing the matrix. Now I'm just going to copy this and and then the same equation can be used to find the transpose. That is, I'm just going to give T of ji is equal to a of ij, like we discussed. And then after that, this is not required, so I'm just going to delete that. Then again, to print the transpose matrix, I'm just going to copy this code. This is for printing matrices. And okay, I'm just going to paste it. Then the transpose matrix is, okay, now the number of columns, number of rows is n and number of columns is m for the transpose matrix. And here we can print the transpose matrix. Okay, so these are the main modification done. This is the code I added for finding the sum of the, not for sum, for finding the transpose of the matrix, and also the number of rows of transpose matrix is n and number of columns of transpose matrix is m. Okay, now I'll just compile this and test this. Okay, now I'm just going to clear this. Then okay, for compiling, GCC transpose dot c, then hyphen out transpose dot out. Then I'm just going to run this program, transpose dot out. Okay, so size I'm just going to give 2 3, then elements 1 2 3 4 5 6. Okay, now we observe this is our matrix and this is our transport matrix. Okay, now the next program is to find sum of two matrices, and here we are considering a matrix A which is of order m by n and a matrix B which is of order p and q. Okay, now before finding the sum of two matrices, they should be compatible in order to perform addition. Now compatible means that the order of the matrix A should be equal to the order of matrix B. That is, M should be equal to P and N is equal to Q. Then only addition is possible. Otherwise, addition is not possible. Okay. For finding out the sum of the matrix, we can just use these two for loops. That is, for I equal to 0, I less than m plus I. Then for j equal to 0, j less than plus j. C of ij is equal to A of ij plus B of ij. That is, we will be taking each element from A and B and adding it together and then putting it into C of ij. Okay, that is, A of 0 0 will be added to B of 0 0 and it will be placed at C of 0 0. Okay, so this is a simple step. We only have to put this particular step, and like we did before, on each iteration, that is, this is iteration for each row and this is iteration of each element of the row, we will be adding A of I and B, A of ij and B of ij to get C of ij. Okay, so just go through these steps and you'll identify, you'll understand how this works. This is our program. This is an algorithm written in the form of pseudocode, and this is our program. So we have a matrix A, then B, then C is for storing the sum, Mn is the order of matrix A, and PQ is the order of matrix B, then I and J are for looping purposes. Then first we have read the size of matrix 1, that is M and N, then we read the matrix A, then after that this statement is for printing that matrix. Then the steps are for entering these, for reading the size of matrix 2, which is stored in P and Q. Then the values, all the values or all the elements of matrix P is read using these statements. Then after that it is printed using this statement. Okay, it is printed using matrix 2 is printed using this statement. Then after that, in order to allow addition of two matrices, it should satisfy the condition such that M not equal to P or N not equal to Q. Okay, that is, M should be equal to P and N should be equal to Q. In any other cases, addition is not possible. That is, order of matrix A should be equal to order of matrix B. Okay, that is, M should be equal to P and N should be equal to Q. Okay, if that is not the case, then if M is not equal to P or N not equal to Q, then addition is not possible. If this condition is false, then we should find out the sum. Okay, for finding out the sum, simple two for loops are used. First for iterating through the columns, and first for loop for iterating through the rows, and second for loop for iterating through each element in a row. And in each element we will be computing C of ij is equal to A of ij plus P of ij, and after that the statement for printing the sum matrix. Okay, I will just compile this program. And okay, so GCC sum of matrices dot c, and output it to sum of matrices dot out dot slash sum of matrices dot out. Then the size of the matrix 1, that is, I'm just going to give 1, or I'm just going to give 2, 3, not 2, 2, and elements are 1, 2, 3, 4. So this is our matrix 1. Then I'm going to enter the size of matrix 2, which is again 2 and 2. So I'm just going to give 4, 3, 2, 1, and the sum matrix, this is our matrix 2, and this is our sum matrix, which is correct. Okay, now I'm just going to give another example. I'm just going to clear the screen, and then here I'm going to give size of the matrix is 1, 2. So and the element is 1, 2, and second matrix is 2, 2, and the elements is 1, 2, 3, 4. Now here this is the matrix 2, and here addition is not possible because order of matrix 1 not equal to order of matrix 2. Okay. The next program is to find product of two matrices, and here we are considering matrix A, which is of order m by n, and matrix B, which is of order p by q. And if n not equal to p, then multiplication is not possible. If n equal to p, then multiplication is possible, and the product matrix will be of the order m by q. Okay. Now in the example we are considering two matrices, A which is of order 2 by 3, so m equal to 2 and n equal to 3, and B is of order 3 by 2, so p equal to 3 and q equal to 2. And the resultant matrix will be of the order m by, here matrix multiplication is possible since n and p equal to 3, and also the resultant matrix will be of the order m by q, which is 2 by 2. Okay, now since we are finding the elements of the product matrix, we will be traversing through each location, so we will be using these two loops for that. For I equal to 0, I less than m, then plus plus I. For j equal to 0, j less than q. Okay, here it is of the order m by q, the product matrix, so here it will be m, and j, it will go from 0 to q. Okay, now in order to find the element of product matrix, that is, for example, consider C of 0, 0. How we can find that? We can find that by adding the product of elements at row 0 of A and elements of column 0 in B. Okay, now if you observe here what we do is that we will be computing A of 0, 0 into B of 0, 0, that is 1, then plus A of 0, 1 into B of 1, 0, which is 6. 1 plus 6 equal to 7. Then we will be finding out A of 0, 2 into B of 2, 0, which is 3, and then again adding it to 7. Thus we will be getting 10. This is how we will be actually finding out the product of the numbers, product of element in our product matrices. Okay, now if you observe here, for finding out the element at C0, 0, here we here the row of matrix A will be always staying constant, that is 0. Here the column value will be changing, that is, in matrix A it will be traversing through all the columns in that particular row. And if you consider B, it will be traversing through all the element in column 0. That is, here B0, 0, B1, 0, B2, 0. This value is constant. Okay, so here 0, here 0. Here the A of row value is constant. This is changing, that is the column value. For that we are actually using K. Okay, and here if you observe, the column value is same but row value is changing. That's why we have given here it as k of j. Okay, so this is the loop for finding out a particular element in product matrix. For k equal to 0, initially Cij will be initialized to 0, then k less than n, then plus plus k, then C of ij is equal to C of ij plus A of ik into B of kj. Okay, so once these iterations of k is completed, we will get the sum of product of elements of row 0 of matrix A with that of column 0 of matrix B. Okay, this is the equation that we will be using to find out the sum of the matrices. Okay, I will just go through the code. So initially this was our matrix A, this is matrix B, and this was empty. So initially I was 1, I less than m, here m is 2, so which is true. So again it will go to j loop. Now j less than q, here j is equal to 2, 0 is less than 2, so it is true. So again it will go inside k loop, and here k equal to 0, k less than n equal to 3, 0 less than 3, it is true. So it will go inside the statement where we compute the value of c of ij. Okay, c of ij is equal to c of ii, that is here. Sorry, c of ij is equal to c of ij, initially value of c of ij is 0, is equal c of ij plus a of ik, that is a of 0 0, then into b of 0 0. Okay, here k and j are 0, so we multiply this with this and we will be getting the value 1, and it will be stored or updated here. Okay, now the k value increments and k becomes 1, 1 is less than 3, again a of ik and a of kj is taken and they are multiplied and it is added with the existing value of cj, so it will become 7. Then again value of k is incremented, 2 is less than 3, so again a of ik and b of kj is taken, that is this value and this value, and product of those two values are taken and it is added to the location c of 0 0, that is the value becomes 10. Okay, then again value of k is incremented, now 3 is not less than 3, so it will exit from the loop, and again the value of j becomes 1, 1 is less than 2, so again it will go inside k loop, now k becomes 0, 0 is less than 3, so again the value at here and here is taken. Okay, now we are finding out the value of c of 0 1, that's why here first value of row 0 of a is taken and first value of column 1 of b is taken. Okay, and this process is continued till we get all the values for Cij. This is the final table. Just go through the table and understand how these iterations works. Okay, this is the entire program for finding the product of two matrices. Here A is first matrix, B is second matrix, C is for storing the product matrix, M by N is the size of matrix A, then P by Q is the size of matrix B, then I, J, K are for looping purposes, used for looping purposes. Then we have read the size of matrix 1, that is M and N, then we have read all the elements of matrix 1, then we have read the size of matrix 2, which is P and Q, then we have read all the elements of matrix 2. Then if n not equal to p, okay, then matrix multiplication is not possible, else we will perform the matrix multiplication, and then here two for loops, and we have the product matrices order which is of the order m by q. So here the two loops will be for I equal to 0, I less than m plus plus I, for j equal to 0, j less than q plus plus j, and then in order to find the element of product matrix at ij, we have to iterate through all the elements in row I of matrix A and column j of matrix B. Okay, and then we have to find product of those numbers, and then we have to find sum of all of those elements products. Okay, that's what what is done here using this k loop as we have discussed earlier. And here Cij is equal to 0 is initialized here. If you want, you can just cut this, and you can also write it here, both will work. Okay, for simplicity I just wrote it here. Okay, so every element is initially every element Cij is initially given the value 0. Then we iterate through the row of matrix A and then column J of matrix B, and then we find out the product of those two and then add it to Cij. Thus, after the end of this loop, we will be getting the value of Cij. Okay, the logic is same as we discussed earlier, and this is the code for implementing that. Okay, now then we have this statement for printing the product matrices, or for printing the product matrix. Okay, so we'll just compile this program. There is gcc product of matrices.c hyphen output to product of matrices.out. So I just compiled it. Now I'll just run this program. That is dot slash product of matrices.out, and it is asking for the size of matrix 1. It is, I'm just going to give 2 3, then elements 1 2 3 4, then 3, then 2. Okay, and again size of matrix 2, I'm just going to give 3 2, elements as 1 2 3 4 1 and 0. Okay, and the resultant product matrix will be 10 10 15 20. Here the order of matrix 1 was 2 by 3 and order of matrix 2 was 3 by 2, so the resultant product matrix will be 2 by 2. Okay, and here matrix multiplication is only possible because here this value and this value are same. Okay, now we will try out one more example. Again, I'm just going to clear this. So I'm just going to run this program again. I'm just going to give sizes 1 by 1, then I'm going to enter the element 1, then I'm going to sizes 2 by 1. Okay, I'm just going to enter the element 1 2, and here matrix multiplication is not possible because this value is not equal to this particular value. Okay,